The last couple questions from the Desmos activity from yesterday was kind of a variation of looking at area and circumference. So I want to talk about those two, and then we're actually going to define what you were looking for when you attack those two problems. Hopefully, for the most part, I saw good answers on the first problem because they talked about the goalie eating half the pizza. They said the diameter was 20 inches for that pizza. But again, they were just going to eat half of that. So you did a nice job with that one of figuring out, well, if I find the area of the entire circle, which in this case would be 10 squared because the radius would be 10, times pi. If I were eating the entire pizza, I'd have 100 pi square inches, but she ate half, so we know we just had to divide that by 2. So you could have had 50 pi, or some of you multiplied it out and got 157.08. Again, it would be square inches. Then for the length of the crust, well, the length of the crust would be essentially half the circumference. So circumference we know is pi times diameter. But I ate half of it, or she ate half of it. And so the length of the crust would have been 10 pi inches, or if you multiplied it out, 31.42 inches. Okay, so those two weren't too bad. And like I said, for the most part, we did a good job on those two things. When you got to the next one, this time they said that she chose a slice from another pizza. This pizza had a diameter of 16 inches. And the slice that she took out had a 45-degree central angle. Well, something to think about in relation to that is if I thought about this being a circle on the inside and I took out a 45-degree angle here, that means I'm going to take the same amount as far as degrees from the circle itself. So really I'm looking at 45 degrees out of the entire circle. Well, the entire circle we know is 360 degrees. Or in other words, if I were to look at that section, I've taken 1/8 of the entire pizza. So to find the area of the slice, I would find, first of all, the area of the entire pizza. So that's going to be this time 8 squared pi, 64 pi. And I took 1/8 of that, so I'm going to divide that by 8. And so the area of that one slice would have been 8 pi, or approximately 25.13. And again, that would be square inches. When I look at the crust, well, now I'm back to looking at circumference. So circumference would be diameter times pi. But we still have 1/8 of that entire circumference. So the circumference, or that piece then that would be on that slice, would have had 2 pi for the crust, or 6.28 if we multiply it out. So whenever I'm talking about a portion of the circle, I may be looking at one of two things. One of the things I may be looking at is a portion of the area. So if I'm looking at a portion of the area, what I'm really looking at is what's referred to as a sector. That would be the portion of the area. If I'm looking at a portion of the perimeter or the circumference, that's referred to as the arc of the circle, or a portion of the circle would be considered the arc. In terms of the example here with the pizza, well, the slice of pizza would be the sector, the crust on the pizza would be the arc. So on this one, they say that as the evening drew to a close, Sonia noticed that there was only one slice of the goalie's pizzas. That was the one we did originally, the one that had a diameter that was 20 inches. So this was a 20-inch diameter pizza. But she noticed there was one slice left. For some reason, she had a protractor with her, I guess, but she decided that the central angle was 72 degrees. So they want to know, well, what's the area of that remaining slice, and then what's the length of its crust? So the first question really becomes, well, what would be the area of the entire pizza, which we already decided was 100 pi. And then we've got to think about, all right, well, what portion of the circle would 72 degrees be? So I've got to figure out, well, what is 72 out of 360? So if I look at 72 out of 360, I find out that's 1/5 of the circle. So I'm going to take the entire area and I'm going to divide it by 5. So the area of my slice would have been 20 pi for this one. And that would be square inches. If I multiplied it out, we'd have 62.83. By the way, when you leave it in terms of pi, like I did here, that's referred to as an exact answer. So if they ever ask for the exact answer, that means don't multiply it out, just leave it in terms of pi. All right, what about the crust? Well, the crust would be dealing with circumference. The circumference we said earlier was 20 pi. We still have 1/5 of the circle. So the length of the crust would be 4 pi inches. Or multiplied out, it would be 12.57 inches. So really, when we look at these sector problems, these arc length problems, we're just looking at what portion of the circle do we have for this situation. And then we just find out what that portion is of the entire circle itself. So again, a portion of a circle, like the crust of a pizza, is referred to as an arc. So anytime you hear them reference an arc, they're talking about what's that portion of the outside of the circle. Or another way to think about it is, if I put a piece of string and I started it at one point, I put that string down on the circle and I ended at another point, how long would my string be? So I'd like you guys to try this one. This one says the length of an arc is a part of the circle's circumference, which we just talked about. But they said if the circle has a radius of 6 centimeters, I want to know what's the length of the arc when I have a central angle, so this angle right here, that's 30 degrees. All right, so pause this one and see if you can figure this one out. Okay, when you tried this one, first thing we want to figure out is, since I'm dealing with the arc, what's the circumference of the entire circle? Well, they said that the radius was 6 centimeters, so we know our diameter is 12. So if I were looking at the entire circumference, I would have 12 pi. I only had a portion of it though. So they said 30 degrees. Well, that's 30 degrees out of 360 degrees. So 30 degrees out of 360 means I have a 12th of the circle. So I'm going to take this 12 pi and I'm going to divide it by 12. So that tells me that that arc length is really pi centimeters long, or it's 3.14 centimeters long. So that would be an example of an arc length problem. If I have a region that resembles the slice of a pizza, that's referred to as a sector. So it's formed by 2 radii of a central angle and the arc between their endpoints of the circle, which is a fancy way of saying you've got a radius here, and then the arc that connects those two things together. What it's really talking about, though, is a portion of the area. So if we know a circle has a radius of 10 feet, we know the central angle is 20 degrees, we're going to try to find the area of the sector. So again, try to find the area of the sector here. So pause the video and then come back and see how you did on it. All right, how are we going to attack this one? Well, the area, if the radius is 10, it's going to be 10 squared or 100 times pi. 20 degrees, well, that's 20 degrees out of 360 degrees. Or if we looked at that and we actually divided it out, we're going to find out we have 1/18 of the circle. So I'm going to take that 100 pi and I'm going to divide by 18. Now, when I do this, if I keep it in as an exact value, I probably want to reduce it down. So this one would become 50 pi over 9. And that was in feet, so square feet. But I could also multiply it out if it didn't say anything about keeping it exact. So this is going to be approximately 17.45 square feet. Now, if you're getting slightly different answers than that, I've been using the pi button to do my calculations. If you use 3.14, that's fine. As long as you're showing me your steps, then you're going to be okay on this. So arc length is a portion of the circumference. Sector is a portion of the overall area. All right, last problem here. Let's see what's happening in this situation. This one says a certain car's windshield wiper clears a portion of a sector as shown shaded at the right. So the shaded part would be where the windshield wiper covers. If the angle the wiper pivots during each swing is 120 degrees, or another way to think about it is that's our central angle. We want to find the area of the windshield that's wiped during each swing. Notice that a couple things given to us. The distance from here to here is 5 inches. The distance from the center all the way to the edge is 5 plus 15 inches. Okay, so that red value would be 5. The blue value, though, would be the 2 put together. All right, again, pause the video, take a shot at this one, see how you can do it. All right, well, let's see what we can do with this problem here. We kind of have two situations going on. We've got a sector of a circle, but then we also have a portion of that sector that's taken out as well. So if I were attacking this one, what I would probably do first is I would think about, okay, well, what if this part that's not shaded in were shaded in? What part of the circle would I be looking at? Well, first of all, if I made this entire circle, and I'll do the best I can creating a circle, that large circle would have a radius that is 20 inches long. So the area of that entire circle would be 20 squared, or 400 times pi. But we don't have the entire circle again. This time we have 120 out of 360, or we have 1/3. So I need to divide this by 3. Well, 400 over 3 does not reduce very well, so as far as exact values, that's as far as I could go. If I actually go ahead and multiply it out, though, I'm looking at that large sector being 418.88 square inches. But we didn't have all that sector that was shaded in. This part was not shaded in. So I need to figure out, well, how much area do I need to take out? Well, in this one, the radius is 5, so we're looking at 25 pi. It's still 120 degrees, so even though it's a smaller circle, there's still 360 degrees in it. So I'm still looking at 1/3 of the circle. So let's see what I would have if I multiplied that out, because I can't really reduce that one. That's going to be 26.18 square inches. And since I'm taking that out, we're going to subtract those two values. So if I take the 418.88 minus the 26.18, I find out the area would be 392.7 square inches. So really nothing new on a type of problem like that. It's just taking it that extra step and kind of problem solving some steps that you might have to include. So if you have to attack a problem like that, I'd want to make sure that we include everything that I had to do. I had to find the original sector. I had to take out the area of that sector that was not shaded in to ultimately find our solution.